Okay, we have here our example for area between graphs. This is an application of integral calculus. So we have our problem. Find the area of the region bounded by the graphs of y is equivalent to the square root of x, and y is equivalent to x squared. So if you have noticed, we have here two graphs. We have y equals square root of x and y equals x squared. So first, we will write this one as y squared is equivalent to x. And then this one, of course, it will remain as y is equivalent to x squared. So this is our solution. Now, to solve this one, again, we have to draw the graph in order to visualize this problem. So we have here our x and y. Okay, coordinate. Now, for this one, y equals x squared. Remember, this is a parabola wherein it is linear in y. So the parabola is opening at positive y. So supposed to be, this is the drawing of our parabola. That is y is equivalent to x squared. Okay? So this is our parabola y equals x squared. That is linear in y. So parabola is opening to positive y. This is our x. This is our y coordinate. So opening to positive y. On the other graph, this is linear in x. In other words, it is opening, parabola is opening to positive x. And of course, the vertex is at the origin. So we have this one. This is our parabola. Okay, so this is our parabola, which is y squared is equivalent to x. So we have here two graphs. Again, parabola, we have this graph, and then we have this graph. So we have two parabola. Now the question is, find the area of the region bounded by the graphs of. So in other words, we're going to find this region which is bounded by two graphs. So y equals x squared, we have this one, and then y squared equals x, we have this graph. So the area which is bounded by the two graphs are this area. Okay, now to solve this area, we will apply a vertical strip. In calculus, we will apply vertical strip. Okay, so we will apply vertical strip. So, in our vertical strip, we will be using area is equivalent to the integral of, okay, y dx, which can be rewrite as the integral of, so I will erase this one, okay, integral of y high, we will be using y high minus y low dx. Okay, so dx, so y high is the y value, this is our y high, this is the y value of this parabola, and then our y low, we have this point, this is the y value of this parabola. Okay, so how about the limits? Okay, so we must compute the limits. Take note that this area started from this point, which is from the origin. Okay, since this is dx, we are going to compute the dx. So this is the other one. We're going to find the value of x here. Okay, the value of x here. So in other words, our limits will start from this point up to this point, wherein there is an intersection of our graphs. Okay, so how do we find this point? Of course, we will combine the two equation. Okay, so to combine the two equation, remember the two equation, we have here y equals x squared and y squared equals x. So I will be using this one, this formula, I mean this graph. We have here y equals x squared, and then y equals this graph, x equals y squared. So instead of writing x, I will substitute the value of x from this graph, which is equivalent to y squared. So we have here y squared raised to 2. This is x squared, since x from the second graph is equivalent to y squared, so I will write here y squared. I will substitute the value of x as y squared, so we have this one. So this is now equivalent to y to the fourth. Okay, so if that is y to the fourth, y is equal to y to the fourth. Okay, so how do we find the value of y? So that means dividing y, you have here y is equivalent, no, this is y, we will cancel y, so what remains here is 1 y cube. Okay, so that y is equivalent to the cube root of 1. Okay, so I will erase this one first. I will erase this one. So y cube root y is equivalent to cube root of 1 is, you have here 1. Okay, cube root, this is y cube, so cube root of 1, that is equivalent to 1. So if y is equal to 1, going back to this one, what is the value of x? So for this graph, if we use this graph, if y is equal to 1, so square root of 1, the value of x is equal to 1. So in other words, this point, this intersection is 1, 1. Okay, 1, 1. Again, that is the value of this point. Therefore, we can declare now our limits. So area, going back to this one, I will write here area limits is from 0. It will start from this point to this point of x, which is equivalent to 1. And then I will write here y high minus y low dx. Okay, so area is integral from 0 to 1. What is y high? We have here your y high. The value of y high is y value of this graph, which is the square root of x. Y equals the square root of x. So you have here y raised to 1/2. Okay, y, this squared transfer to the other side, that becomes square root of x, or x raised to 1/2. So y raised to 1/2, that is your y high, minus your y low is this one, the y value of this graph, y low, which is equivalent to x squared. Okay, sorry for this one, y high is square root of x, or x raised to 1/2, and then this one is y is equivalent to x squared, and then that is dx. Okay, so that is x raised to 1/2 minus x squared dx. So if you are going to use your calculator, you will have your final answer, which is equivalent to 1/3. Using your calculator, you can find the value as 1/3. Okay, as 1/3, of course, this is square units. Okay, 1/3 square units. Okay, so this is now how we solve area of the region bounded by the graphs of y equals square root of x and y is equal to x squared. Okay.